Bismillah ar-Rahman ar-Rahim. Today, inshallah, we'll start talking about IP address version 6. So at the beginning, we need to talk about the limitations in IP address version 4 that led to the development of IP address version 6. Unfortunately, the way that the material is structured, I expect students when they read the material, if the video was not there, it would be very hard for you to understand these limitations and why IP address version 6 actually solved these issues and how and things like that. Because in order to understand it deeply, you need to understand some concepts from transport layer. You need to understand some concepts that we will talk about later. So I will give a little bit of an idea about these concepts now, as much as I can. But if you don't understand it 100%, stay tuned and we will explain it later on. Okay. So first, IP address version 4 is depleted. Depleted, it's exhausted. Well, IP address version 4 is only 32 bits, and the allocation of, this is more important, the allocation of IP address for a network is coarse. Coarse معناها it's not fine-grained, which means I cannot easily say I will move one address IP from this network to this network. It doesn't work this way. So if you have, for example, a lab with a number of hosts, 64 hosts, well, you can allocate 64 IP addresses. And now there is another host that came recently. Unfortunately, you cannot just say, I will add only one address. Because the way the address allocation happens is that it's either 32, 64, or 128. Because it's based on 2 to the power something. So even though you have one host added, but you have to add 100, or you have to have 128 addresses in this network, which means that potentially you will end up with many addresses that are not used. Not only that, in the early days, they were allocating the IP addresses based on classes, based on clear discrimination. So there are very few networks on the internet that each of them will have 2 to the power 24 different hosts, and there are only 127 networks over the internet, which is what they refer to as classful IP addressing. In any case, the allocation of IP addresses happen in a very coarse way. It's not fine-grained. I cannot just say, take one address from here, put it in this network to accommodate the growth in this network. It doesn't work this way. So this actually helped the depletion of IP address version 4 to happen rapidly. So we have 32 bits, which accommodates 2 to the power 32, which is around 4 billion addresses. But it's far from being enough. Okay. Of course, the population is more than 4 billion. And not only that, each one of us has like several devices. And depending on your location, you may be in a network which has like 120 addresses, whereas there is only 2 or 3 that are being used, and the rest is not being used. And that's why they came up with DHCP to allocate these addresses dynamically. But again, you cannot allocate 65 addresses for this network. It's either 64 or 128. So the allocation is coarse. It's not like fine-grained. So, in IP address version 6, the allocation is still coarse. However, the domain of IP address version 6 is huge. So the coarse allocation is not a problem. It is a problem for IP address version 4 because it's only 32 bits. Okay. Type. Router table expansion. By router table here, we mean the routing table, the table that the router uses to route the packet. Okay. Because the number of traffic on the internet is growing day by day, the number of networks on the internet is growing, and therefore the routing table on the router is growing. So this is still a problem for IP address version 6, but we will see that it's not as severe, and it's not at least worse. Also, IP address version 4 uses the concept of NAT, or network address translation. And we need to understand this concept, even though it's not explained in the material, but we need to understand it in order to know how critical and how serious this problem is for IP address version 4. The problem is that, if you know, in our houses, we have a network, and we have only each one of us in our houses, we have a network with several devices, right? And we have one router which is connected to Ooredoo, the service provider. What some of you may know is that Ooredoo assigns only one address for us. Ooredoo gives us one address per user.
The NAT?
No. Ooredoo gives you one address only. One IP address, which is what we call public IP address. Okay? This public IP is assigned to you, and you use it to communicate from all your devices. So how can, because we said that IP is unique, right? So how can we use one address to facilitate the communication from multiple devices at home? That's why they came up with the concept of NAT. Of course, to combat the IP address depletion. And this concept is based on the following. So we have a range of private IP address. This private IP, it's a specific range. Like, for example, if you notice in our houses, we have very commonly 192.168. something. Okay? This range of IP address is private, which means that it only has significance within the local area network at home. The host sends a packet with the private IP, okay, and it sends to a specific destination. The destination is always public IP, because the private IP is not actually visible to the internet at all. Okay? What the router does is that the router uses the concept of NAT, network address translation. It will take this packet and it will change it. It will change the public IP, as the private IP, into a public IP. And this public IP is shared for all devices. Okay? So network address translation talks about the fact that you change the private IP into public IP when you send the packet. The router. Yes. So that Ooredoo, the service provider, should never receive a packet with a private IP address. If it does, it will drop it.
Why?
Because private IP has only significance in the local area network. Okay? So using this concept, it helped the IP address version 4 to stay alive for quite some time. Why? Because the private IP address, because it has only significance in the local area network, now all of us can reuse these IP addresses at home, right? So the same range of IP address can be used on multiple networks because they are not visible to the internet, right? So you can use that range, I can use that range, anybody can use that range. And then the router will use NAT to change it to public IP. So that violates the uniqueness of IP. This is number one. Okay? The problem with that is that as we have explained before, if you have a network and you have a router here, and this router talks to many routers until you reach to the final destination. The packet will have logical IP addresses and physical IP. As we said before, the logical IPs, the source IP and destination IP, they should never change during the transmission of this packet end to end. صح؟ مش كلنا كده؟ What does change? The physical address. The physical address will change depending on the router. So at every hub, the physical address will change. The logical address should never change. Therefore, this logical address, the set of the source and the destination addresses, can be used to identify the end-to-end communication, because it does not change, right? NAT violates this. NAT actually changes the source IP address from private to public. So it violates that concept. So all of a sudden you lose the end-to-end connectivity. You don't know which host in this LAN sent this packet. You know that this network sent this packet using the public IP, but the public IP does not refer to which host in the LAN sent this packet. So you lose the end-to-end connectivity, and that violates the uniqueness of IP address. But, well, do we have a choice? Well, the developers said, no, we don't have a choice, because the IP address is depleted, and this is the only way that we can keep IP address version 4 alive for quite some time until we come up with IP address version 6. So IP address version 6 came with a revolutionary mentality. So we need to make a serious change, a fundamental change, not just. It is implemented. It's working. It's working, but not in the entire internet. And we'll talk about these issues.
Doctor, in our home, when we send anything to Rido, Rido doesn't know that this device.
No, nobody on the internet knows that except this router. What the router does is that NAT is bidirectional, so it actually has a NAT table. So this NAT table has supposedly two columns that says this private IP has been changed to this public IP. So on the way back, I will have to change the public IP back to private IP. Is there an issue here?
Yes.
What is the issue?
I don't know, but it doesn't sound very easy.
It doesn't sound very, it cannot work that easily. You're right. The problem here is that on the way back, I can change it. So what if two hosts send two different packets? So now I have to store the fact that this is private IP address 1, private IP address 2 is sending to, and I had to change the router will say I had to change those two private IP addresses into the public IP, which is only one. So now on the way back, should I send it here or here? It's a many-to-one relationship. That's why it's not that easy. Okay, so how can we solve this problem? So we need to have another piece of information that will make this relationship one-to-one. And the developers, they came up with another piece of information which is already used, but not in the network layer, in the transport layer, which is the port number. In the transport layer, as we will study later, there is a port number. So the port number, so a host, it sends from a private IP using a specific port. So there is port 1 and port 2. So on the way back, I can use HENA. This is the incoming port 1, port 2. The router will use the public IP, which is common, and another PR01 and PR02. So it does not change only the public IP. It changes also the port number to make this relationship one-to-one. So this way, on the way back, I can map from port 1 and LP1 and the public IP back to that specific host. So this relationship now is one-to-one. What is the problem with this? The problem with this is that the router had to read the header of the transport layer to get the port number. And that violates the layered stack أصلا. We talked about layer stack, encapsulation, decapsulation, and we said that the data part is actually, for us, it's abstract. So it had to violate so many things. Had to violate the uniqueness, end-to-end connectivity, and it had to read the port number from the segment in the transport layer at the network layer in order to change it to the public IP and another port number. They had to do severe
والله دكتور basic يعني they are ready to change and do whatever they want.
Well, the idea is that they had no other choice. They had no other choice because of the depletion of IP address version 4, because the problem is that when they came up with the idea of IP address version 6, they thought about it and they said that this will take several years. And it took over 10 years to develop and come up with IP address version 6. They knew that they need that, but IP address version 4 still needs to be alive for quite some time until we move gradually to IP address version 6.
Can you version 5?
No, there's no version 5.
Why did they call it just immediately 6? Was there a reason for 4 to 6?
Because they wanted to indicate that the change is drastic. It's a revolutionary change. It's not just because to keep IP address version 4 alive, they had to come up with some evolutionary solutions. One of them was moving from classful IP to classless IP using the subnet mask. We'll talk about this. Another thing is using variable length subnet mask. We'll talk about this. And we use DHCP for dynamic allocation of IP. So this will keep most of the IPs active as much as possible. So they did so many things just to make sure that the usage of IP is as efficient as possible. But that does not provide a fundamental solution. Okay? And they knew that the future growth with IP, with the Internet of Things and stuff like that, it needs some revolutionary approaches. But revolutionary approaches always take time. Okay? So they needed some transition. And these techniques, like NAT and everything, it kept IP address version 4 alive for the last 10 to 15 years, okay, with the depletion that's happening. And we're communicating. The problem with private IP is that it's not easy to set up server at home. If any of you tries to set up a server at home, it's not easy. Okay, because of using NAT, because the server needs to have a static IP. And this IP needs to be visible to the internet because people need to access it. It's easy to use clients because clients, they initiate the communication. So you know the address of the server and you can communicate to it. But in order for your server to become usable, it has to have a static IP. And NAT hides the IP from the internet. So how can people access it? There are some workarounds for this, okay, but it's not as revolutionary as like IP. With IP address version 6, now it's not a problem. You can assign IPs as we like. The domain is huge. They jump from 32 all the way to 128. So the domain of IP address version 6 is, we don't even use that word, is 340 undecillion. Undecillion is like 10 to the power 36. Okay? So it's huge. And we're not expecting to run out of IP address version 6 in the next centuries. Okay? So that's how fundamental the change is. But this has some implications. Okay? So some of the characteristics of IP address version 6, in addition to the fact that the address domain is huge, IP address version 6 eliminates NAT. And this way we can gain back the end-to-end connectivity. Now, the IP address, when we say IP address does not change, we're serious. IP address does not change. Okay? So the end-to-end connectivity can now be identified by a source and destination. We don't need NAT. At least we were not forced to use it. We can use it for some other purposes, but we're not forced to use it because of the shortage of IP. Also, IP address version 6 has a built-in feature for security. And we'll talk about what exactly in the header field that's used for security. Okay? So
they remove checksum from IP?
Yes, that we'll talk about this. Yes. Okay, so now we need to answer these questions based on the discussion. And one thing I noticed here is that really, this is what's good about these exercises. Some students, they don't really get the question, and this is a serious problem. So we need to really train ourselves how to understand the question fully, so that the answer will be precise. Because in many cases, I find students they answer with lots of words that it does not really give you a precise answer. But they try to confuse the reader by having like so many words that really does not address the answer. So we need to train ourselves about this. Okay? So we need to. So why the IP address version 4 is depleted?
Because adding the IP address 2 to the power.
Right.
You can't add one.
Because address allocation is coarse. It's not fine grained.
So Dr. 2 to the power something.
Yes. So 2 to the power 6 or 7 or something like this. So it's either So it's either 64 or 128 or something like this. Fine grain. يعني I can add one address from here to here. Fine grain يعني small. يعني that your resolution is very small. Will the router table expansion be an issue for IP address version 6? No, why? No. شفت? This is an example for how you don't really get the question. I'm not talking about the address domain. I'm talking about router table.
You said yes.
This is the routing table. This is the routing. The routing table has destination address and interface, because a router has many interfaces. It needs to read the destination address from the packet, map this to what we will call later a network address. Okay? And then from this network address, it needs to know what interface to send this packet to. It's like an intersection or a roundabout. So the roundabout needs to say whether the car goes this way or this way. What we use for this is the destination address in the packet. Okay? So the problem with IP address version 4 is that because of the growth of communication, the end-to-end communication on the internet, this routing table is growing very rapidly, is growing large. So is this also a problem for IP address version 6? And if it is it worse or is it the same? Or there is no problem at all? That's a tricky question. That's why I warned you at the beginning, is that in order to really answer these questions, you need to understand some concepts, which some of them we will talk about later. But we kind of have to give you some idea now in order to be able to understand these characteristics and issues. So the answer is yes. IP address version 6 still suffers from the routing table growth, our routing table expansion. But the problem is not worse than IP address version 4. So yes, it's there, but the issue is, remember that the router routes from one network to another, not from a host to another. So when the address domain grows very large, that doesn't necessarily mean that the number of networks will grow as large, right? This means typically is that the number of hosts per network will be very dense. Okay? So you will have lots of people in the same network, but not necessarily the number of networks will grow very large. So the problem is still there in IP address version 6, but it's not necessarily worse. Even though the address space has expanded drastically, but the routing table will not grow with the same proportion. Why? Because the number of hosts per network will increase, but not necessarily the number of networks. And this is what people will expect in the future. Each one of us is going to have probably like more than 10 or 20 devices. So your glass is going to be connected to the internet. Your clothes is going to be connected to the internet. You will have lots of devices. Okay? So this makes the network dense. This makes the network dense. But the routing table will not necessarily grow. Why? Because the routing table routes from one network to another, not from one host to another. So all these group of hosts, they will have one network address, which we will talk about, one network address in the routing table.
The first three numbers are the numbers that are public, right?
First three numbers?
I mean,
No.
The first three sets of numbers.
Not necessarily. We'll talk about this. Not necessarily. Sometimes 2, sometimes 3. It depends on what range of address you're talking about. هنتكلم عليها in details. Don't
Because I thought the last part was
for the actual host, صح?
Because usually they
Not-
are the only difference.
Not necessarily. Not necessarily. It could be only 1 byte at the end. It could be 1.5 bytes. It could be 2 bytes. We will talk about this in details. ما تقلقش.
Doctor, IP version 6, eventually networks will increase, even networks, routers will increase, and
But again, not with the same proportion. يعني just the fact that احنا we have expanded the domain how many times? كتير, صح? But the number of networks will not grow with the same proportion.
but it will pass
Never.
the number of IP version 4. Lower
What?
maximum networks in IP version 4.
What I'm trying to say is that don't expect that the expansion of the routing table will happen in the same proportion like the expansion of the address domain. They are not proportional. خالص. Because the expansion of IP address version 6 would mean that the networks will be very dense. But remember, within a network, what do we use to send in the network access layer? We use the physical address to send within a local area network, the MAC layer. The MAC layer will take care of this, right? So if the network is dense, the only restriction now is that I cannot have more than 2 to the power 48, which is the size of the MAC address, within one network. And that's huge. This number is huge.
That's not gonna happen.
It's not going to happen. You will almost never have MAC address depletion. That we know. Okay? The problem is with IP address depletion happened very fast. And the fact that we expand the address domain, that doesn't necessarily mean that the router table will expand in the same way, which is good news. Okay? Because again, the router routes from one network to another, not from one host to another. Okay? Type. Why NAT violates the end-to-end connectivity? We talked about this. So we said that because of the change of IP address, so change of public IP, I'll change to public IP, violates end-to-end connectivity. What else?
Layer distribution.
The use of port violates a layered stack. Okay? It violates the uniqueness of IP أصلا. It has several issues يعني. Okay? طيب. So based on that, IP came with some characteristics. So these questions, to answer these questions, will help us to understand these characteristics. 4 questions related to the 4 characteristics. Very quickly. We still have 10 minutes. Oh, okay. Okay. So we'll have 2 minutes to answer these questions, and then we'll discuss. So why increased address space is useful? Okay. So we will have enough IPs. We will have enough IPs for مثلا for IoT مثلا أو في we will have plenty of IPs for everyone. So how IP version 6 improves packet handling? Because that's one of the characteristics that IP address came with, that it does improve packet handling. So how does it do that? As we will see, is that the header is more simplified in IP address version 6. One example that we talked about before, checksum has disappeared. So this actually improves packet handling. Why? Because I don't have to do error checking at every single hub or every single router. Okay, so less processing. So header is simplified. As an example, checksum or no checksum. Which means less processing per packet. Okay? Type. Why eliminating NAT is useful? To have مثلا end-to-end connectivity. No violation for IP uniqueness. Okay, so that's how eliminating NAT will be useful.
It doesn't eliminate the stack.
No violations, no violations for IP uniqueness or layered stack.
So it eliminates all the variations of NAT.
Right. So what will help IP version 6 provide security per flow? The word per flow indicates that, again, we need some identification for the end-to-end flow, okay, so that we can provide security. IP version 4, again, does not do that because even the source address and the destination address, they may change using NAT. IP address version 6 not only eliminates NAT, but as we will see later, is that it uses another field called flow label. Okay? So the flow label not only identifies the end-to-end connectivity, it identifies the flow. For example, if you have a web page may have a video, audio, text, and so on. Okay? So all of them are sent from the same client to the same server, or from the same server to the same client, right? I can give each one of these components a different flow label. And this will help the router to identify the flow, not only the application, but the flow. And this way, I can treat video differently from audio, differently from text, and so on. So that the source address and the destination address will not give me this flexibility, because source address and destination address, they will give you all the web page components from the source to the destination. But now I can use the flow label to have more fine-grained quality of service and per flow behavior. And also use this flow label to identify the end-to-end connectivity for security and other things. So I can use flow label as identifier for end-to-end connectivity, and this way I can use it as a key. I can use it مثلا as a key or something to identify the end-to-end flow. So this will again, the security is not done by IP address version 6 only, but having these fields in the header will help have the security in place. But it's not just like built into IP address version 6. Okay. خلاص. Okay.